So what we really want to do today is make sure that each one of you is able to contribute and lend expertise to how Rick's technology could be useful in India and could also accelerate the very big challenge that we have of emerging contaminants. And particularly, Rick's going to talk about arsenic today and the opportunity to both identify and treat for arsenic so that you can have water available where it currently is not due to compromised systems. So I'll just share a little bit about Rick. He is the CEO and he's the founder of Aqua Metrology Systems. He's been a great partner to Global Waterworks almost since our start, well, for the last 3 years. And he is, as I said, founder of AMS. Prior to joining AMS, Rick held senior management and board level positions in the energy, industrial, technology, and water sectors. And Rick has a keen interest in technology, startups, and innovation. He's led AMS through their development and commercialization of online, real-time analytical and remediation solutions to predict, control, and treat a range of contaminants in drinking water, process, and wastewater. Rick holds a degree in land economy from the University of Cambridge in the United Kingdom and a PhD from the University of California, Santa Barbara. Rick is in the heart of the United States innovation sector in the Silicon Valley area of California. So he also understands the very dire straits that the state of California is in right now, one of the most innovative states in our nation for water management. And with that, I will turn it over to Rick and suggest he take about 15 minutes or so, and then we engage in a Q&A. And so Rick, you should be able to share your slides, and just thrilled to have you with us at this early hour. And I would acknowledge Rick is doing yes, he's still up from yesterday to stay fresh.
Thank you, Mary, for that intro, and thank you for everything that Global Waterworks does for this industry and bringing us together in a forum like this, and to Hari and your colleagues for inviting me to this meeting. I have a brief presentation. I'm going to try and put it on full screen, and hopefully begin. Slideshow from the beginning. Okay, I hope everyone can see that. That's the intro slide, which you've done for me, Mary. Can everyone see the slide? Is it loaded?
Yes.
Yeah. Okay.
Sure, we can see this. Yes, please. Go on.
Okay.
Please.
Sorry. Yes. So brief. We've been around for 10 years, which is, so we call ourselves an old startup. You have to be an old startup in this industry because it takes so long to get anything to happen. But over that time, we've built we're very much US focused, because when you're a startup, you can't go all over the world. But we are building a position in the Far East. We've started to put our feelers out into India, opportunities there for manganese and iron remediation, chrome remediation, and into Malaysia as well. So very much US centric today, but that was by necessity. That's where the money was, and that's where we were. So what I wanted to begin this with is a recognition that it's a paradigm that we all face. And I think sometimes there's a thought that, well, you know, India is different from the US, different scale, different lots of different things. But actually, I think there's some common underlying features that the world water industry faces. And that is, by and large, most technologies were developed for large cities and large communities, and they're not scalable. And there are lots of reasons why that happens. And it's also the reason why vendors focus on that, because that's where the money is. And, you know, but in terms of dollars and growth. Another feature, which is very much from the vendor perspective, is that their model has always been razors and razor blades, printers and printer cartridges, sell something today and then make a lot of money on the back end for the lifetime of the technology. And those costs are often many, many times higher than the initial capital cost. In fact, sometimes the capital is sort of priced in order to win those lifetime revenues. And that's problematic. And it often gets lost in the conversation. And lastly, treatment system vendors, they sell their capital. It comes with no guarantees, and they're gone. And whether that system performs well or not is generally the problem now of the new owner. That doesn't happen when you buy a car. If it starts breaking down after 5 minutes, you take it back and get it fixed, and it tells you what the petrol gas consumption is, and. The water industry seems to not worry about that too much, and the costs end up with the person who bought it. And so how do we change this paradigm? And it's a paradigm that applies as much in the US as it does in India. Yeah, I grew up in a very poor rural community, and at times we didn't have safe drinking water. That was in the UK. And I can drive 50 miles from San Francisco, where you have the poorest communities without safe drinking water, with arsenic, with chrome, with PFAS. So this is not just, I don't think, an India problem. I think it's a global problem. But I do think that out of this conversation, we can bring a perspective that it can address the needs of all of those communities, wherever they are, because it's a common problem. So I want to begin with, how do we address this? And I think the first thing is that we need data. It's all very well talking about, the problems of whatever contaminant, unless we know what's going on in a water system. And a laboratory is nowhere near good enough for that. You'll take in a sample, you'll get it back 2 weeks later if you're lucky. And in the meantime, the water quality, whether it's the raw water or the treated water, will have changed 100 times, from safe to dangerous, from dangerous to safe. And so we began life very much focused on delivering real-time, high-quality data to asset owners. And what we came to realize, we really initially focused, and everyone said, oh, well, we don't need real-time for regulatory readings, that's far too costly. Well, we never sold it for regulatory readings. We sold it on the basis that we could help water treatment system owners optimize their processes. If you don't have real-time data, it's like driving a car in the dark without headlamps and without a map. You just do not know where you are. It also became apparent that with real-time information, you can shut down a system if it's not working before it pollutes the rivers. And industrial operations often get away with polluting when the technology is there to stop it happening. But there are other uses of this data, particularly when new technologies are being brought to market, which is to validate them before you actually let them loose on the unsuspecting consumer, and validate that this technology is actually doing what the vendor promised. And we've been involved in dozens and dozens of projects where we've been employed by engineers to actually validate that the technology that was promised to reduce selenium or arsenic is actually doing what the vendor claimed. So it's a different use of real-time data, but it's a very valuable one. And this is just a very simple explanation of all of that. So this is one of our very typical installations. It's arsenic monitoring. And the regulatory limit, as you know, in the US is 10 ppb. The yellow dots is the real-time data of an arsenic treatment system, servicing customers in the southwestern United States, quite a large population. And the blue dots, which are really important, are validation and calibration. So the analyzer is constantly monitoring itself, because you can talk about data and data and data, but if you don't know you've got a false positive or a false negative, you might as well not have the data. And so this is telling you that the results you're getting are accurate. And at some time during this treatment process, and this is real data, I didn't invent it, the coagulant tank, ferric chloride, ran empty. And you see that immediately the numbers shoot up. But they had a buffer tank, so it was good practice, and brought the numbers back very quickly. So still drinking water, but then the pump on the buffer tank failed, so double failure. And again, the numbers run out very, very quickly, run up very high, and but the operator is alerted, is able to go out, fix the pump, whatever they did, and bring the water back into compliance. Now, this doesn't matter whether it's a big city or small community. If you don't have that data, how on earth do you know that your system is delivering safe drinking water to the consumer? And the vendor of that technology has long disappeared. So I'm not going to spend a lot of time on this, but these are our core products. They range from being able to monitor online a wide range of trace metals, trimethanes, which is a very high profile contaminant of concern, particularly in Europe and the USA, a range of inorganic contaminants, and then on the right, a benchtop scale analyzers. And the advantage of both is that they can handle very high volumes very quickly, very accurately for whatever contaminant you're interested in. And so this is much, much faster than a laboratory, and particularly for dispersed communities, it can be a solution. I don't want to spend a lot of time talking about technology because I don't think that's sort of the core for today, but we've spent a lot of time doing this. The reason we're in Silicon Valley is because we monitor the treatment plants, semiconductor plants, and they have very, very high demands in terms of performance. So over time, we've developed some very powerful proprietary technology that ensures, firstly, accuracy and precision in the results. You saw what I demonstrated earlier on for arsenic, but in natural matrices. Because if you're looking at any instrument, it doesn't matter what it claims about performance in distilled water. How does it perform in real life water full of inorganics or organics, which are going to be interferences? And secondly, because it was semiconductor heritage, we needed to know that the analyzer itself was performing. And so our analyzers actually carry out ongoing self-diagnostics, and they will tell us if they're sick and need fixing. So a number of features that make these analyzers extremely powerful, extremely reliable, and with very, very high uptimes. And if you don't have that data, all of this talk that goes on in these conferences about digitalization and Internet of Things and digital twins is a house of cards. Yeah, without data, everything falls over, which is why I began this talk focusing very much on data. I've talked briefly about that, one of the analyzers, which I think is particularly suitable in terms of getting quick results to asset owners, regulators, and so on. So, because by accident or by design, we began in real-time monitoring, but because we became the sort of the brain on many treatment systems, we became the controller, the policeman of many treatment systems, which is why I talked about some of the weaknesses of them earlier. We became very aware of the failings, or the not failings, limitations of many traditional treatment technologies. And they're listed there on the right. I won't go through them, but from an asset purchase point of view, what we've seen is that many times purchasers don't think about issues of scalability, labor requirements, whether there's any automation, the engineering burden, dealing with toxic waste, handling the waste, and the actual reliability of the system, its uptime. And all of these drive lifetime costs. And that's the real burden. You know, it's easy enough to get a grant often to build the system, but who's going to pay the bill at the end? So we have developed an in situ, so on-site reagent generation system. And any of you who are aware of on-site hypochlorite generation, which has increasingly replaced the use of bulk hypochlorite or chlorine, so bulk shipments of those reagents, this is a very similar model. So we are using electrolysis to generate on-site 2 reagents. for treating a wide range of contaminants found in drinking water and wastewater. Now, we haven't invented the chemistry. That's been well known for a long time. But what we've done is automated and developed a system that is highly automated and highly controlled so that it can deliver on demand, as needed, more or less, a dose of the relevant reagent to treat for those contaminants. It can also be used, incidentally, for corrosion control management in heating and cooling systems, but that's not today's focus. It is highly competitive compared to the traditional systems that I listed earlier. And it comes with a brain because we consider that we must be accountable for the performance of the system after it's installed. And because we have the data, and this is quite a unique feature because we generate the data from our analyzers, we can provide both real-time control, but also guarantees of performance over the lifetime of the system. So we look upon this as
sorry about that. Yeah, please go on.
So this is a truly digital solution to solving water treatment needs, and it is scalable. And I'll come to that in a minute. So essentially what we're doing is using, most of you would consider this electrocoagulation. However, the problem with electrocoagulation has always been that it treats the total volume. So these electrocoagulation units for anything of any size are just huge. But the other problem with electrocoagulation is the electrodes become passivated. So whether it's for a small community or a large community, it's not a practical solution. And what we have developed is a method of taking a side stream to the mainstream to be treated and injecting into that the relevant reagent, ferric or stannous, and then re-injecting that back into the mainstream. And because we're doing this on a side stream at very small scale, we are able to use proprietary technology to avoid the passivation of the electrodes. So one of the biggest Achilles heel of electrodialysis we have resolved. And electricity, whether it's solar powered, is not an expensive consumable, and nor is iron or tin. Very readily available, very cost effective. And so we're able to produce a very controlled amount of these reagents in situ and on demand. And this is where I think, this is where we go from shipping barrels or tankers of, depending on the size of the location, of reagent. In this case, it's ferric, could be ferric chloride or ferric sulfate, which is used widely in communities big and small in the US and around the world. It's the sort of go-to chemical for many places. However, it's very expensive relative to generating that same chemical in situ. So there's a significant cost saving for whether it's a small community or a big community that is able to use this technology for replacing bulk chemicals. And that probably sounds a bit theoretical, but we've actually put this into practice in several locations. And this is a compact, it's a pilot, so it's probably not as pretty as it will finally look when the whole system is put together. But this ran for several weeks and is relatively small scale. It's certainly not household, and there are limits to how small we can go, but it is relatively small, and we've developed it here in California to address the needs of hundreds of communities that do not have safe drinking water at a cost that is a fraction of the alternatives. The alternatives, in fact, so expensive that they cannot be deployed. And this can be used to service small communities. but it can all be scaled up to multiples, 2 million gallons a day, 8 million liters a day in terms of treatment, and a fraction of the cost, because we're not moving bulk chemicals around. There is no toxic waste. It's extremely efficient. And you will have gathered most of the advantages of I've been talking about them. But this is a low cost, low lifetime cost. That's the important thing. Consumables are only tin and electricity, and no toxic waste. It can be, the waste can be disposed of in general landfill. From a carbon footprint point of view, environment point of view, it's also very attractive because we're now not moving around large volumes of chemicals, several of which are hazardous, which requires special storage, special training to handle them, and. And it's produced on demand. So it's ideal for communities that where wells are unattended, where there isn't skilled labor. All of this can be automated and controlled. So that's our solution for a range of utilities, not maybe down to one household, but certainly to communities where until now technologies have not been available to service their needs. So when I talked about the earlier paradigm, this is, I believe, a way of disrupting that in a very positive way, maybe not for the other vendors, but certainly for the communities that we're interested in servicing. So it's proven, it's scalable, it's controlled 24/7. It will shut itself off if something goes wrong. It will alert when something goes wrong. It's fully automated, cost effective, and there are no toxic waste streams. So that's a very, sorry, I talked very quickly, but I knew I had limited time and I wanted this to be a conversation. So I hope that gives you a sort of high level picture, not only what we do, but the philosophy behind what we do, which we're very, very strongly committed to.
Applause, Rick. That was wonderful. And I think you provided a great context for the need for a new approach to this toxicity assessment and also the treatment, but you also shared some great examples of how this is coming into place. And what I'm wondering too is you have, I believe, a financial model that allows for this to be even more accessible to people. Could you just talk about that a little bit so the gentlemen understand? And then just when we have questions from people, I'd like you to share the context from which you're coming from, so you can think about that so Rick understands the role you play in India's water systems and America's. Thank you, Rick.
Yeah, so just quickly to answer that question, as I alluded to earlier, the razor blades model has sort of been sell and walk away, which serves the interests of the vendors, but not necessarily the community, the end user. And so we feel very strongly that we can offer, because we can offer guaranteed performance, because we've got the data we can share, we can actually say to you or your clients or who's buying, we will treat your water with whatever it's got in it for X cents per gallon. You produce more, you produce less, it becomes a variable cost. Yeah. So it becomes very transparent. So if a city has to invest in an arsenic treatment system, they can say, dear consumers, yeah, we are going to have to charge you, a cent a gallon more, whatever the number is, in order for you to have safe drinking water. Because there is another paradigm which sort of says that water should be free for all, but it comes with a cost. So whoever pays for it, there is a variable cost here. So essentially, in the language of the industry, it's design, build, operate with performance guarantees. Mm-hmm.
Yeah, a beautiful model. I guess I'd ask Hari. I see you're, Dr. Hari, you're leaning forward. You have some thoughts on this?
You said design, build, operate, Rick. Vikas has a very similar model, uncannily, but in a slightly different context. And he's, well, I'd like him to speak about it. Why would I want to, stand instead? Yes.
Yeah. Thank you, Dr. Hari. Thank you, Mr. Rick. Thank you, Mary, for the wonderful session. I am Vikas Brahmawar. I have been in the industry for the past 12 years. We have been working on water treatment equipments. Before that, I used to be a software engineer working in the UK, and then I wanted to solve something in India in terms of water problem. I returned, and for the past 12 years, we have been working on water. I will share my screen. 1 second.
Instead, Vikas, instead of you going into what you're doing, I'd like you to respond specifically to what Rick said on the model that he believes is working well for him in the United States, especially on the Pacific side where he comes from. You know what he said about Silicon Valley and the challenges of semiconductor plants and so on. While you know he also recognizes, being himself a person from a poor community from the UK, he knows intuitively the challenges that we have in India. So how do we make this relevant to India is my question to you, in response to what Rick said.
Yeah, so here in India, we have CapEx issue where people don't believe in technologies, and people don't want to invest on a capital equipment which they cannot operate. The biggest challenge is people have complicated technologies, and on the field, people are not able to operate. So it works really well when it is OpEx based, where every liter of water is charged.
Right, and that's why I thought of you, because Rick said design, build, operate is the key. You know, your model is on more or less a design, build, DBO model. I mean, I'd like to think maybe you can share with Rick and the rest of us here. And I must add for all of you out here, every single person who is in this meeting is a CEO, Rick. You know, or a strategic senior manager or a senior strategic manager or whatever. Over to you, Vikas.
Yeah, so we had issues with the large malls here in Bangalore, large malls who had enormous amount of wastewater. We set up systems at our investment and we charge per liter basis for them. So now it becomes completely our responsibility to supply water to them at the desired quality. And the client doesn't have to worry on equipment maintenance, all that. So it becomes really a suitable model and win-win from all sides, from us, for the client, and it's easy to maintain as well. So I think that's a way forward for all cities in our country. That's a way forward. Yeah, Rick.
So maybe I could challenge that. So I used to work for Severn Trent, which had a very large design, build, operate business. And the challenge, if they had a sophisticated buyer, which many times they didn't, but when they did, it was more problematic, was how do you guarantee the quality of the water that you're delivering? Because if you've got a sophisticated buyer, they're going to say it's 100% of the time below 10 ppb arsenic. And if it's not, you're going to pay a penalty. And we need that data. How do you address that?
Here, as you do, we also have this remote monitoring data where we, since it is recovery of water, we have the TDS limit, the hardness limit on those parameters. In this region in Bangalore, we don't have arsenic, but we have in other regions, we have arsenic, fluoride, nitrate, and other issues. Where we have this remote monitoring solution where our dashboard says what is the quantity of water, what is the quality of water. If the quality, if the TDS say exceeds 80 ppm, then they don't pay us for that water. So there's a strict real-time monitoring. So without real-time data, it is very difficult to assess per liter basis because they're paying per liter. How do you measure per liter? So yeah, Rick, you're right. That's the only way for boot model. We have to have real-time data.
Good answer. Well done.
Yeah.
Absolutely. Yes, very.
Go ahead.
You know, I was just saying that, you know, like Rick said earlier about data, and you know, you can have all these wonderful systems and there will be a house of cards, your IoT and AI and so on. What Vikas is saying is also true, and I think the market is shaping in that on those lines just now, and the next 10 years is going to sort of determine these things. You will not get paid if you don't know how to determine your outcomes on the basis of real-time data. Over to you, Very.
Yes. I think I want to share with Dr. Nandakumar from ICCW about a vision that Rick had, which we shared with some innovation labs here in the United States. If they could innovate at the pace of time, because they actually get feedback real time on what they're doing through labs or through treatment. Rick thought we could speed the pace of innovation. And since you lead this innovation hub, the idea of having access to real-time monitoring like Rick has might be beneficial to all of those who are executing and trying to manage treatments and show the effectiveness of them. But Rick, maybe you could explain a little bit about that capability that you have, so Ananda Kumar could comment.
Oh, thank you, Mary. That's really a really helpful interjection. So I'm always concerned about the cost of doing anything. And there's a cost of developing new products, testing new products. I'm a firm believer in lean development, lean R&D. And the problem for a lot of water treatment technology vendors is that you set the system up, you then take a sample now, and you then have to wait 2 weeks to get the result to know whether it's doing what it should be doing. So if you can remember what you were doing on Monday when you took that sample, that sort of helps, but it's still very late. And then you change it and you go through the whole process again. And with real-time data, we had a project here in the Central Valley. It was it's an agricultural project removing selenium. And they actually cut the time of the project in a quarter because they were able to do all of that in a compressed time frame. And all of that's cost. It's either cost for someone vending it or supporting it, granting it, and getting the technology into the market. So it's the time value of money, if you like. Do something quicker, faster, and get to the answer faster, and then deploy it faster. So yeah, real-time data is a time value for money benefit.
Okay, if I can respond, thank you, Mary, and thank you, Rick, for that wonderful presentation. It gave me goosebumps somewhere, because this is exactly what we've been grappling with. We've been trying to see how close we could get to real-time data for water, and in India, it's been very challenging. If we are in a position to get what you're saying about real-time monitoring of water treatment plants, we could also do it at the input level, where there is variation of water quality with season, with the geography, and with the withdrawal that goes on. The rate of withdrawal can also create some problems. So I see a lot of opportunity, one for data analytics, because you will be collecting huge amount of data real time, which beyond data privacy, I don't know if there are issues there, but if it is possible to take this data and analyze it, we could probably predict future trends in areas where arsenic may appear, or where it could disappear if there is a trend. And so that's one possibility that I see in terms of prediction and interpolation or extrapolation of data that we would have. The second thing, of course, is that the cost of measurement and the timeliness of it can make a big difference. Its value is, I don't think I can estimate it today, but if it's possible to, relate it to customers, specific customers who have challenges of costs and impact, if in case something goes wrong, I see niches where we could start. Pharmaceuticals, for example, or food industries. I'm looking at industrial sector one. And the other is communities, which are in vulnerable areas, where the municipality or the administration can face challenges. It could be monsoon. I don't know if you are also able to measure to some extent about pathogens or contaminants, but if we are working on that, if it is possible to integrate the chemical, physical, and biological contamination, and use the sensor to stop or collect samples instantaneously if something goes wrong, and if it's repeatedly going wrong, can we stop the process? There are many things that we could build around it, what I can see. If it is affordable in India, or if it is not affordable in India because of it's made outside, we could look at indigenization and help startups. We are in touch with maybe partner or organization and see if there is something we could do here.
You make several very interesting points. I've just addressed the first one because I want to give everyone a chance to talk, but I didn't talk about controlling and understanding influence. And many times
We're losing you there on the network. Rick, we lost you there. Maybe you should come back again on your last sentence.
Okay. Many treatment systems fail because there's an unpredictable level of influent, and it overwhelms the treatment system, which was designed for an average flow. And so that creates a problem. So if you've got analyzers at the beginning in the influent, you can anticipate that and take evasive action. The other thing is that everyone knows that levels can fluctuate. So engineers will design for the worst case, which again is more cost, right? Rather than taking a mitigating action, which is much lower cost, why not build a big palace for any circumstance? So there again, it's we talk about the value of the data. The value of the data is designing effectively, lean design, and your point is very important.
Well, you talk lean design. Nandakumar mentioned earlier about affordable solutions, not technologies. I would love to bring in Chandra here. Chandra, you have been working with tribal communities, with the poorest of the poor. You're trying to see how you can disrupt cost while you want to, keep your technology effective. You have worked with what, 400,000 to 500,000 households just now in the last, say, 7-8 years. You've been innovating in multiple fronts. As you put out in your chat box, you could come up with various designs on, vessels and containers and stuff. What you worked with the CSIR, and to those of you who don't know, there was a wonderful man, a true genius called Mashelkar, Mashelkar, who ran the CSIR, the Central Scientific Industrial Research Institution here in India, for something like, say, 20 or 25 years. And this man, he used to keep saying that in India, it's not about money. Innovation is not about money. Innovation is about ideas. Chandra, in some sense, represents such things. Over to you, Chandra. Yes, Chandra, you have to unmute and speak. You have to unmute. Oh, well, I don't know if I can unmute you. Yes.
Yeah. I think that's a overdone introduction by Hari. He's very passionate and a good person. But
you deserve it. You've been doing some good work.
No, I do it. I'll tell it the other way. Actually, when I walked across almost 2,000 villages in India for something else, to photo document the heritage structures which are lying in ruins. So in India, that is also one other big area where negligence is very much, and the government is losing a lot of heritage treasures. While photo documenting, people were kicking me out of the village, not allowing me to stay back. So I saw water and sanitation was the real problem, because they have to give me some stuff which I cannot drink. And in the early morning, I had to carry a pitcher to go out in the open to defecate myself. So this really hit me hard, and I threw all my job, whatever I was. I'm a plastic technologies postgraduate. I was in the industry for almost 30 years. I kicked everything out and started doing water and sanitation issues. That's why my company is called Watsan. Okay. So cut short, as what Hari said, Malshekar and this team.
We lost you again.
Spread across the country. They had a technology called TerraFill technology, that is terracotta filter. As simple as that. It was a clay candle with nanopores, which doesn't allow the impurities to pass through. Simple percolation, gravity filter. You just fit the candles on the top. You have the unclean water on the top. It will percolate down, and what comes below will be pure drinking water. Okay. So I took interest on that. Interestingly, there were more than 150 licensees who took the license from the government, because government fees are very less. They charge a lakh or so, and they give the technology, they know how everything. But the rheology of clay is very dynamic. Even in the same pond, the clay in different places will behave differently. So the rheology was something tricky. I think almost all the 149 people left this technology because it was also not commercially viable. Making some nano-place candle, giving to the rural people and making a rupee or two didn't excite the businessmen really, but I took it very hard. And I mingled the traditional knowledge of the potters community. I went and talked to them, understood what type of clay are they using, why do they reject some and why do they take some. So by combining, because I was already into heritage restoration, I had good connects with the villages. So I took both the technology, the ancient technology and the science given by CSIR, tailor-made it to make a candle which was consistently giving the porosity, what we need, the nanopores, and the filtration rate, what it was. And that's why I was able to reach out to this 4 lakh Indian households. I want to challenge Rick on one point. Automation and all these things can come only if there is electricity and there is need for continuation. When there is no water, when there is no electricity, what are you going to do with automation? The problem in India is 83% of the Indian rural population are village centric. Rural people who don't know whether the water has fluoride or arsenic, but they die because of all these severe diseases. And I can give you, you just name any village in India, I can tell you whether the village has fluoride or arsenic. Because this was real-time data, meaning by putting a man there on the job, they're carrying our chemical kit, going there, testing it and coming back. The next month you go, the fluoride and arsenic level will go off, as Hari rightly said. There will be a lot of rain or there will be some rainwater harvesting happening directly or indirectly. The water will totally change. So your data meaning also becomes incorrect because the Jal Mission Ministry has data saying that only 4 or 5 states has arsenic, whereas I found it in almost 17 states there is arsenic. Somebody may say Karnataka doesn't have arsenic. I can clearly say Raichur and the belt in and around Raichur has arsenic. Whole of North Karnataka, almost 23 districts has high fluoride. Bangalore, you say it is high iron content is there, but because iron is high, some areas where arsenic is not detectable is not detectable. Because unless I remove iron from the whole thing, I cannot detect arsenic, and there are arsenic in some industrial wells, and that is being drunk by people in bottled canned water. So the challenge is something different. If you see the need versus the instrumentation or the automation, India's need is 83% of the people who don't need automation, but they need smaller systems which can alleviate arsenic, fluoride or whatnot. It can be agrarian land where high phosphate, nitrate, ammonia or high chloride is there. That has to be challenged, that has to be remediated. Because you may be doing good businesses, good turnover by selling few of the big machines which is automated, giving to hotels, 5-star hotels and something. But the Indian people need something really bad. Again, their economical constraint is very high. Affordability is very poor. My filter, as Hari said, is hardly $15, which is being given as a standalone filter with all do-it-yourself. Again, no AMC, no standback. You said you have to monitor continuously and go back and do it. My system is freebie. Like past 12 years, somebody is using and he calls me back and says, sir, what do you do with the candle? It is not dropping. I said, just clean it with a air jet. Your pores are open and again you can reuse. He is so happy. He just uses a cycle pump, clean the candle, the pores are open and again he is going to use it. That is what we emphasize here, because India is a country where this continuous automation, OPEX and CAPEX cannot be taken as a real serious business if you want to look into business. Okay, I'll tell you numbers. 6 lakh villages, that is 600,000 villages carry this 83% of the population who need arsenic remediation, fluoride remediation and whatnot. What you are talking is only the 7% of the Indian population, which are a high echelon customer. They may take yours, they may take Vikas, or they may take somebody else's. Okay, because that is that one moment decision. It may be bad, good or ugly, even that owner doesn't know water treatment properly. He may take it and maybe he may repent for all his life, or he may take it or he may be happy for all his life. But the villager whom I am talking doesn't know anything about technology. He knows only about his pocket, the pocket with a hole. So how do you solve it? That is the big question. Thank you.
Brilliant, absolutely brilliant, Chandra. You know, Rick, I must tell you this. You started this by saying we need, to look at affordable solutions and so on. And we had Nandakumar also say that we need smaller solutions and just quote smaller systems. I'm quoting Chandra. When he says that in his rapid fire ways.
Maybe Rick, it can be a handled portable thing, maybe running with solar, where I can carry to the place, just plug it into the water, take in a bottle where it contains some specific amount of water, put the probe in, then I can detect and say the water. Already Jal Mission has come out with the competition. They have shortlisted 12 or 13 people who are doing this handheld kits, which can be taken to any geography, just to put it into the water and find out the anomaly. The problem was their scaling up was not there. In fact, out of the 13 winners, 12 are with me. They are calling Chandra and saying, Chandra, can you scale it up? Because I know how to manufacture the whole thing. Ideas cannot take you to the market. It is the product which takes you to the market. So that is another thing which you can bring it down to a smaller size. Maybe I can send it to 100 villages in one go. I have one centralized system where I can connect to all these things through cloud, then take it to automation and whatnot. But again, it should be affordable by those 100 villages. That's the call.
One is, sorry, Rick, before you respond, I will acknowledge the presence of Dr. Prakasham Tata, who is coming in here from Chicago. Good morning, Dr. Tata. We'll listen to him too. He's worked here in India in his younger days, and he's been driving, a deal of water initiatives across, even in the United States. The other is, I must tell you, Rick, that in the next 3 sessions of the Tech Talk series, the 3 alternate Fridays that are ahead of us, thanks to Mary, we have got a trilogy of what we call the point of use discussions on water. And well, without Rick and Nandakumar and Vikas and Chandra, I don't see that conversation going forward. So I'll request you all to be there for that discussion. Over to you, Rick, to respond to what Chandra said.
There was a lot there, and so I understand. I am very sensitive to the problem of. I started at the beginning, scalability, right? And we've actually looked with Mary at the Native American populations in New Mexico, where you've got very small communities, poorly served by drinking water and power and everything else, and it is a problem. I mean, let's not beat about. And the technology you need, forget monitoring. I'll put monitoring to one side for a second. There is a cost of metal, a cost of all the things that go into it. A pound of metal or whatever. There is a cost, and you can't be avoided. So, what we came up with for Arizona, New Mexico, Utah was a solution where we would take a well and actually use that well as a central source. So all the wells were contaminated. And so what was happening, they were bringing in water in trucks to service the community. And so they're basically buying in water very expensively. That was their only alternative, because treatment of house by house by house was just impossible. And so our model was to say, okay, we will take a well in a central area, and we got the distribution plan of where all the communities were. And that well will service a broader community. And we will produce wholesale water that can then be distributed locally. And the cost saving of that, again, was very, very significant, because it got beyond trucking in water from wherever it was, hundreds of miles, to service these communities. And maybe, I'm not saying it works in India, but we have to find some more creative solutions than saying this very expensive technology, somehow we're going to squeeze it down to the individual house. I mean, why did we build?
Oops. So, and I'd like to go back to Dr. Tata, as Dr. Hari suggested. Dr. Tata has experience with Rotary and bringing in solutions, and solving this type of situation might be a Rotarian movement. But Dr. Tata, teeing you up for maybe money bags. Tata, I know you've resolved the plastic solution and polio with Rotary. So what can we do?
Let me acknowledge the presence of Mr. V. Suresh, the chairperson of the Indian Green Building Council and the national president for Focus and multiple other things. He brings influence and reach on policy in India, Rick. I wish he had heard some of these wonderful exchanges between Chandra and you, but I'm sure he will catch up. Yeah, there you are. Mary, back to you.
Yes, well, I'd like to turn it over for Dr. Tata's comment on the remediation of arsenic problems in India as a solution that maybe Rotarians might get behind for these small villages, as Wathan described. Huge opportunity, but huge impact too.
You have to unmute, Dr.
Tata. You want me to make a comment on that one? Yeah, see, a lot of efforts what done in the past. It is a continuing problem. As a matter of fact, a couple of Indian people were involved in this, Arun Deb and others. They designed and installed arsenic filters and stuff like that. And also, I think in Netherlands, they gave some arsenic filters as well as defluoridation units. Any of these units that were installed, one of the problems is maintenance and operation. I constantly harp on this point. The donor agencies give these units. We work very hard to raise the money and then try to put these systems, including reverse osmosis systems. And I don't recommend RO systems at all in these areas, because first of all, why do you want to put an RO system on a piped water supply? In the households, I saw this one. The municipal water comes in, it's probably cross-contaminated with sewage or something like that, because the pipes intersect and then some pollution takes place. It is clean water, I mean, from a water quality point of view, except with microbial contamination. That simply can be solved with a UV type of a device. You don't need an RO, because when RO pulls out the salts, and it's not good for health, you know. And WHO has a big report on that one. So these systems, any kind of system at point of use, when you put in, this is the problem I noticed in India. I think even the filters that they put in, plug-in filters and whatnot, are under the sink filters, or even the benchtop filters, you know, treating these waters at the point of use. The maintenance, operation, of course, some of these companies, they offer regular maintenance and all that, but they're expensive. There is no need for that kind of stuff, particularly with the municipal water, with these membrane changes and things like that. So my problem, what I see, the marketing, I love these marketing companies because they are able to sell so many gadgets. Everybody knows water is polluted, even at the point of use in municipal systems. So people are afraid of it, and they have money, they buy these gadgets, and they do that. And that is a no-no. I mean, they should understand, first of all, that they can maintain and operate it regardless of the marketing people, because there's another income for the marketing. I don't blame them, because they're in the business to make money. So I think awareness, again, I tell you, this is a very important thing. They think you put the thing in, okay, I'm safe. No, it is not safe. For 3-4 months, it might work. After that, it doesn't work. Again, water comes in, water goes out. That's it. So these are the kinds of things that I see happening. And so how do you address this thing? I constantly badger when I go there. Operate. It is not the lack of technology. It is not like the units, the gizmos. Plenty of them are there out. But they buy it, thinking that they're safe. Maybe psychologically they feel good. Other than that, if you examine the water coming out of the point of view system, and maybe again, one of the other things also I noticed, see, there are some micro quantities of organic materials in this water coming out. Particularly what happens is attached growth. The bacteria have a knack of attaching themselves so that they get the nutrition from the passing water, the carbon and things. So they take that and they form slime layers, okay? And once in a while, the slime just releases itself from the particles that sloughs off. And then we examined something way back in my college days, you know. You take that water, you have hundreds and thousands of bacteria, because they're bacterial films. So all these are colonizing with that. So the micronutrients they absorb and they attach themselves very nicely, and then they slough off. Okay, these are the problem. So how many of them have really studied that? You know, actually in these kinds of donor organizations giving these kinds of filters. So it's very important. We are trying to give good stuff, but in the long run, it is turning out to be not safe drinking water again after using these gadgets. Okay.
Mary, your turn.
Rick, I think I'd like to turn it over to Rick and Dr. Tata. What Rick did share was a comprehensive solution with the creation of the treatment mechanism right on site, saving a lot of money. But I think the point he raises on the operation and maintenance is a really key one, Rick, which you understand. So how does aquametrology address that? And as a follow-up, I do want you to talk about the youth program, the youth system that you've created for lab testing, because all of these people on the call are very interested in that next generation for treatment and maintenance.
It's the question to me, right? So
Yes.
just on the filtering question, it's exactly the same problem here with lead. Everyone gets given lead filters. You're in Chicago, I think, Dr. Tata, and everyone, the problem solved, give them filters, and no one has any idea how they're performing. And it's sort of wash their hands, move on to the next thing. And the problem hasn't been addressed. So I have a serious concern about in point of use, point of entry, point of consumption filters, just in terms of what they're actually doing over the long run and the cost of maintaining them and an end. So I still think that, why did we develop water treatment companies? They were to do the work for the community. And the only question is, can you find a scaled technology or a distribution system that works for those people who need safe drinking water? In terms of youth engagement, this is a personal thing, right? So it's not company policy, but just the way we sort of approach life. There is an issue about ownership of these problems in the community. The idea that there's going to be someone parachuted in who's going to solve the problem doesn't always work. And we worked with some colleges in California where they were engaged in going back into, they were in Los Angeles, and we gave them, they were interested in understanding water and water technology and so on and so forth, and a large number of them for underserved communities in California. So we worked with them to identify a problem. One of the problems was arsenic in groundwater, but no one really knew the problem. So we provided the technology so that they could go back into their local communities and work to develop solutions based on good data as to what the problems were. So it's a way of engaging, and several of those people then took a decision to become water engineers. Water is not a very sexy industry here in the US at all. When they realized that they could actually have an impact in their local community, it was quite transformational. And we've talked to a couple of those interns coming to join us. So it is a way of building capacity where capacity is needed and engaging the local community.
I'm glad, Rick, that you spoke about these things. Chandra, you have a wonderful, distinguished bunch of leaders out here, including the national chairperson of the Indian Green Building Council. I want you to respond to Rick and to what Dr. Tata said earlier on two aspects of it. One, to paraphrase Rick Bacon, ownership in communities is always at a low. You know this, and you know what the government does when it comes to spending. It's always at the capital cost level. There is no money left for maintenance, right? And the second part is, Rick also mentioned this about user engagement being at its nadir when it comes to projects of this kind. This is part one. Part two is, he mentioned just now water engineers. I want you to talk about your, what do you call them? Your women water or water women doctors or whatever. Go on, please.
Thanks for mentioning. In fact, I want to acknowledge Dr. Prakash Tata's comments. Very bang on target, because everywhere RO has been indiscriminately bumped all over the country. All the big company like Wabag, and I can name them. I don't have anything. Let them take me to courts. I'm ready to face. They have just dumped on the solid waste which has been accumulated by throwing these membranes out. It's a big Pandora's box. If I open it, it's going to be a disaster. Forget about water. The dump what they have dumped in the country is going to be a biggest disaster everywhere across. So RO, in fact, in India has been banned by the Supreme Court.
To those of you outside of India, let me tell you, just one city like Bangalore
Yeah.
One city called Bangalore, which has 12 million people, has about 4,000 water ATMs, they're called. That is, you go to a place, you pay a certain amount of money, and you carry away 20 liters of a can. You know, and this is across India now, like the COVID. It's taken India in all its cities. It's a disease, these RO-based water ATMs.
So answering back to Hari's question, number one, what we did, we started analyzing the rural area, each and every place, wherever we get an order or an inquiry, first thing by default is to check the water there. Because if we say Rajasthan, mentally they will think, okay, my place has a lot of fluoride. Somebody has told them, the government has a lot of things in the newspaper, somebody has mentioned, so they think that whatever water is there will be fluoride ridden. That is wrong actually. Recently in one company, there was a big funder who was ready to give a huge community filter. They gave me a big report saying that, okay, it is fluoride and you immediately install a fluoride filter because ours is electricity free and these are all add-on cartridges. Tailor-made, like what ICCW Nandakumar ji said, we put the cartridge below our terrafill candle because terrafill removes iron. The traces of iron will be out. So you can detect arsenic. Arsenic will be passing through this adsorbent, what IIT Madras did, and water when it goes down will be arsenic. So simple. So just plug and play. So we have taught in YouTube to the rural community. You said about participation. How to plug and play. Do it yourself completely. They can open all my system themselves. They can use the material, nanomaterial, put into the cartridge and plug it. And after use, they know the difference in the water itself. After 2 years or 3 years, depending on the ppb of arsenic, they throw it away the nanomaterial, which is again non-hazardous. And they can again take a refill packet, cut open and put it inside the thing and they can use it. So we have totally discontinued ourselves from the AMC model. Business people don't like it. So RO people literally say, "Arey, what is this? You are not getting any more businesses." But this is the thing what India needs. Second thing on fluoride also. Again, there are a lot of alum and other things being dumped. Okay, it removed fluoride, but the customer's real need was not at all satisfied because the waters were importable. He was not able to drink because of heavy aluminum smell. The smell is so pungent, even though the water is fluoride free, he cannot drink it. So we have to take those type of finer details into the designing of, you said tailor-made, designing the product, something like that. So we had calcium stones doped with the nanomaterial, so that calcium dose is slowly given to the people in nano levels where fluorosis has already hit them badly. So build them the bone strength and the immunity what they want, and also remove fluoride the other side. So tailor-making or even design thinking has to be akin to the customer's need. It is not just blindly, I know technology, I just dump it. Again, when IIT did this material way back in 2009, I was the first man to go and land up in IIT Professor Pradeep's lab. And I took the challenge on myself. Sir, I'll give you within a week's time the cartridge what you are thinking, but I can do it. So he challenged me, Chandra, can you give it tomorrow? Overnight on a lathe machine, we just made the turn to the products and put the cartridge, put it back to Mr. Professor Pradeep first in the morning when he was opening the door. So that really kickstarted the whole collaboration. And today I'm proud to say that with this material, we have reached close to 200,000 households, arsenic-ridden households. Same way for fluoride. So technology is something which has to be understood to the common man's need. It should not be a barrier for him to understand or to redesign himself or get the water in the right way. So this village where a high fluoride report was there, I went and took the report. It was only having high phosphate. That's it. As the, Dr. Prakash Chata said, I just remove phosphate and the water is potable. Not even E. coli bacteria or any pathogen, nothing. It is clean, no color, no odor, nothing. Just to knock off. Why should I put? They were about to go for RO mission, which was costing a bomb. So after educating them, it is more of educating. My science has to be transparent. My science has to be simple. There's no patent or anything. Okay, I have certain design patterns or something, but I acknowledge everybody in the run. In my filter, I say, IIT gave me arsenic filter. PSG college gives me fluoride filter. Acknowledging you is always right, but owning the whole thing, no, because science is radical. Tomorrow, what you do may become redundant and something else may be needed. So what do I do with the pattern? I have to just, when I go in my coffer, they can lay all the pattern papers on top of me and just bury me. So it doesn't matter. So my point is, let us take science in an open way. If you are able to synergize with the think tank here, it's an excellent team here. I'm so proud to see all these people giving their valuable points. We are able to build something tailor-made to the need of that particular geography, that particular people, that particular pocket. I think it should be a successful meeting. Thank you.
Very sensible. Nadia, you're about the only lady here apart from Mary and Usha. And well, if I count Mary and Usha out because they're insiders, you're the only one from the group here.
Yeah, sir, one more comment. You
Yeah.
touched upon the water on wheels and WWW.
Yes.
Everybody know WWW is for internet. I say women water warriors.
Oh.
I tell you why. Because the woman is the only person who is concerned about the economical consent of the house and the health consent of the house. In a village, a typical Indian setting, the man will be boozing and he'll be lying around. But if the child falls sick because of a waterborne disease, the woman will run to the nearest doctor and try to take care of the child. Or if there is no money in the house, she will try to run, pick all the gravel she has, and she will try to bring in some sense to people for 3 square meals of. This is the situation of India. So what I did, I started training these women with the water kit. My water filter carries every vernacular language of that particular state, so that they can understand, read it, and then if they don't know to read it, some of the school children who are nearby, they will read and tell their lady, oh, this is what you have to do with this water filter, how to maintain, how to clean, and what not. Everything has been put black and white, transparent, all transparent. And all the videos are silent videos, which anybody in any language can just run it and understand how to fit and forget. Okay.
Chandra,
This is and the woman warrior, they go one step ahead. Okay. They have started telling about the water filters and the remediation methodology to others. They are not scientists. They simply read it in their own vernacular language. Just take the kit out, do titration themselves, see the color change. We have given the color guide in a piece of paper. See the color change and say, okay, this is having high arsenic or this is having high fluoride. That's it. All are tailor-made. We don't even go there to teach them. Everything is put in a small piece of paper or some video. They will read and they will do. That is one thing. Second thing, women were walking miles together to fetch water. So we said, wow, water on wheels. So the ATM machine, what technology you said, AI, another thing is put onto the vehicle. This ATM machine is put onto a vehicle without wasting a drop of water, without membrane. The whole machine goes to the source of water, pick the water from there, come to the doorstep of this woman and then give water. You have a dispensing mechanism. Okay, there you use electronics. 1 liter, 2 liter, 5 liter, 20 liter. If the village can afford, let it be given free. If she wants to be paid, like, okay, 50 paisa or 1 rupee, which is a very negligible amount, she'll be happy rather than staining herself, walking all the miles together and wasting half day under energy to fetch water.
Yeah.
So this is WWW and W. Wow, water on wheels.
Yeah. In an hour and 10 minutes, we have come, the full spectrum from Rick saying that technology has somehow confined itself for all the wrong reasons into those places where money lies, From there, we have come to this where, in many ways, when I'm listening to Chandra, I'm thinking of Mashelka, because this guy kept saying, hang on, buddy, don't look at technology in ways you can make money out of it, but make it in ways that you can, bring change across these. At that point in time, it was about 500 million people. We are today about 800 million people, like Chandra said earlier, who are outside of our cities. We just don't want to recognize this in this country, or anywhere else. Anyone who wants to speak on this, please.
Before you go, Dr. Hari, I just want to have Nadia, if she could speak on the women's reference, and she is actually a great support to Rick. So a bit of an insider, but very informed and excellent commentator on water.
Hi, thank you, everyone. Thank you. Nice to be here. Arsenic is actually a really interesting topic for me because that is probably the first thing I started working on over 20 years ago when I joined the water treatment industry. So that was right when the World Health Organization had reduced the limit. We were propagating a new rule in the United States, and really it was an issue, and we had to look at, and that was at the time I was working with Severn Trent Services, and we were looking at what's affordable, how do we implement something, how do we bring a new technology to this market. So there's a part of me that's really excited when I sit on the call and I hear the ideas that are happening, and then there's also another part of me that's frustrated to think, wow, we're still kind of talking about the same things 20 years later. And I don't think it's systemic of our industry, it's just systemic of culture and what we choose to place value on. So I agree with some of the comments made earlier about the impact, really the impact of women and what we have the ability to do in terms of, I believe it was Mao, he said, women hold up half the world. And, when you look at how you affect change, it's with mothers. We're the ones responsible for taking care of our community. So I'm excited to hear what's being discussed, and I'm hoping that it's not another 20 years to have a solution where people, not just people in the industry, but just people value the water.
Yeah. Nadia, when you say 20 years, I look back and I see that I started work in these areas in 1987. So you add another, I don't know, maybe another 13, 14 years. And you said it's systemic. You said something about culture. In fact, this whole series of conversations that we are having in two platforms, one these Fridays, another one on the alternate Saturdays, is not about technology. It is not about solutions. And I'm glad today, look at the quality of this conversation. This is about, shall we say, on one side, enrolling vision, and on another side, about securing acceptance and securing and having people see the sheer direness of the threat that is before us. So these are the three elements in some ways, Nadia, that keep coming through. And, I'm glad you said this, and you heard, Chandra talking about how, husbands in this country only drink in the day and play cards, and they don't do nothing else. It's the women who run everything, and it's the same across. You go to that arc of Africa, for the Arab Africa, for instance, or you come to Indonesia, you come to any parts of Asia, you will find this challenge of women doing nothing. Men doing nothing. Back to you, Mary. I'm glad she said, 30, 40 years and systemic. We need to do something about this, Mary.
Yes, well, I agree. And what's beautiful is we have the technology now. Nadia knows, she's been working with the technology. And so we have a few different initiatives that are saying, like, for the past 20 to 30 years, we've talked about problems. For the next 20 to 30 years, let's solve them and make sure we're not in that place next year. So I see just 5 people here that could be part of a key user group or advancement group. Vikas, Watson, Nadia, Rick, and Dr. Tata, and perhaps Nanda Kumar with ICCW. And if anyone else wants to be in that user group, I'll put your email in the chat, and we can make sure that we continue sort of a side discussion around these groups. And just a thought, Dr. Hari, is maybe we add the tech talks and then add a roundtable discussion where the groups are able to make progress after these discussions. But we can figure that out later. I know Dr. Tata raised his hand, and if anyone else has a question, please put it in the chat. If we don't get to it today, we will we'll make sure. Oh, Dr. Tata, go ahead. You're on mute. Congratulations.
Tell us more about it, Prakasim Garu. You got to tell us more about what you're showing us.
And you're on mute.
Yeah, you have to unmute yourself. You have to,
Thank you. Now, see, when I first did the project, that's what a dream project in a village of 400 so-called scheduled caste and scheduled tribe people close to my hometown where I was born. I held hands with women in this 400 people community because I know a mother or a grandmother, if she says to the child or to the husband or the grandson, they will listen, okay? Because I want this project not to be a failure, because a lot of projects were just put in place, but why they're failure? Because nobody is following it up. The lady in the house doesn't say anything about it. And she's the one who's cooking in our villages and so forth. So what I did was, before I even installed the project and get the money from the Rotary to do that, I held hands, had the meetings with them at least 10, 15 times, going from the United States to that village, sitting there, talking with them, holding hands. Would you use the latrines I built? Would you use the water that we're going to supply? So, and even the WWM, in the water and waste management, we have a women leaders section for 2 days. Mary knows that. And, these are the kinds of things we gave women, water warrior, okay? Just a little token of our appreciation to the people who participated and who advocated this kind of an approach, and a human approach that you were telling Dr. Hari, you were talking about maybe Nadia said 20 years, you are telling maybe 30 years or 35 years. I am preaching for 45, 50 years.
Right.
Same thing. But what is the use? You go out there, they listen to you. But this project, which I did in 2003, is still working. Why? Because I took the time. Even the Rotarians didn't go there. When I went there, even on my annual trips, they would tell me, sir, you are coming more often than the Rotarians in India. Because they want the picture to be in the paper that they inaugurated the project. That's the end of it. I'm sorry to say that. And most of them are men. Okay. So women power. I advocate.
Yeah. Mary, if I have your consent, we have another, say, 12, 13 minutes. Vikas had one or two slides, and Rick was, I mean, if we can shift the conversation to the challenges in cities of such management of water quality and monitoring of water quality, it might help. Because you had, I know you have prepared something, that you wanted to show. Maybe you want to do that in the next 3-4 minutes and have the other distinguished minds here engage on it.
Yeah,
Yes,
definitely.
Sounds good. And while Vikas brings up his slides, I just want to have Rick comment. Given all you've heard, 600,000 villages, this huge opportunity, we'd love to collaborate. But what is your desire for India, Rick, as you're hearing from these distinguished gentlemen before Vikas starts?
Okay.
If Rick, you're on mute, sorry.
This is, go on, Vikas. Is that Vikas who is showing this? Rick or Vikas?
Vikas. So
Rick.
We'll come back to Rick before we close, just on that comment.
You're right.
That was
right.
super.
Sure.
Go ahead, Vikas.
Sure.
Yeah. Thank you. I greatly appreciate Mr. Chanda's inspirational intention and passion to solve each one's problem. The issue which I see currently is it is not easily available for solutions for urban cities to access solutions which are easy, and people end up buying RO because it's easily available. So I think that point I wanted to make. I'll go back to my slide in terms of, I think we have covered during all our sessions, we have covered all the other areas which we see. These are some data I have from actual problems we have in terms of say arsenic. If you see the slide on the left hand side, we have 239 million Indians face arsenic in different regions. Now,
can you put that on a view mode, please, so that it becomes larger? Yeah. Sorry.
Yeah. Is it clear now?
Yes, please.
Yeah. So this is the scale of the problem. So generally in the city, we all generally worry about TDS, hardness, scale prevention, the fixture getting spoiled, but the majority of population which actually suffer in the rural areas are, we have 239 million people suffering from arsenic. This is the data which we get in the news and all the data which we have. Now, the solutions for this generally on a government scale, which is put is either ferrichloride, or it is not a point of use system which government pushes. Government pushes something which is for the whole community, and they don't look at point of use system. And generally those systems which government put fails because it is not monitored, it is not measured. So I understand the point where individual houses, people are given the freedom of testing their own water easily, but how fast can we reach 239 million people? Now, to bring that scale, government scale, we need data which can be monitored. I have one more set of data. This is a sample, which is 40 samples, which has been taken in Bangalore city, pre and post monsoon. So if you see, we have all the contaminants in terms of heavy metals, all these carcinogen being present. So now, if we have a point of use system, why are people not adopting? Because there are so many contaminants in the water. So people end up reverting to completely RO. Say, for example, people say Kaveri water, Mr. Tata, Dr. Tata said RO needs to be banned. Supreme Court has banned for use of RO for TDS more than 500, but banned for TDS below 500. But most of the cases we have TDS above, for borewell water above 500. So people don't have access to point of use equipment. So when there is a good intention in terms of serving millions of people, there has to be a sustainability which needs to be bought. For sustainability and marketing needs to be bought, it has to be run like a business, because if you invent new technology, IIT or Mr. all amazing minds inventing new technologies, if it doesn't reach people, if it is not available in Amazon, if it is not available to common people to understand, then how are we going to solve this problem? Now, few of you said you have been seeing this for the past 20 years. We will see again next 20 years, because if marketing, if it is not run like a business, it won't scale. So that is where I think good minds has to look at. I invent a product, how can I make it reach 239 million in next 3 months, next 6 months? That is where we'll have to see, we'll have to look at. Now, coming to our focus, we have been focusing on various regions. We have sold 750 plus systems on industrial, including RO, water treatment, all these. So we have seen in Tumkur region, this fluoride removal is generally done using activated alumina. And all the government, these are the technologies which government use on a standard, on an application level. I understand the point of use system, but government uses only these large things, and generally they implement it. It runs for 3-4 years, and then after 3-4 years, it goes out of proportion. And I feel there is a lack of intervention in terms of boot model, things like that, where a responsibility is given to a company for a period of 10 years, 15 years. So it ensures that there is a consistent quality coming out. So I think I will stop with this. We have other slides. I stop with this. I believe for a government level intervention, monitoring becomes necessary. And for an individual level intervention, point of view system becomes necessary. And point of view system needs a lot of marketing. They need to make money to create this marketing budget. Only then we will not hear about this in the next 20 years. Thank you. Thank you very much.
I would rather give a small comment on Vikas thing. They had never spent on marketing. All the 4 lakh people were reached because of the self-help group and NGOs who happily took it. My budget on marketing is very minimal. It's making those brochures in vernacular languages. Number 2, you said governments do it on larger scale. They are fully corrupt. Let me be open on that. To go into GEM and put a tender on paper, the technical description is tailor-made for one particular company. Why should they write the description of the filter medium or the technology? They should simply say the water should meet IS 10500 standard. That's it. Let technology be any damn thing, yours, mine, or anything. Why is the government under writing those description of vessel, description of membrane and whatnot? And that is purely tailor-made, and that is the reason businessmen with proper sense will not go into government tenders and waste their time. Because I have to have a lobbying, I have to do all those things. If I lobby for 2 full years in Punjab, I can get that Punjab tender.
I got that.
What I did, I happily gave it to IIT Madras because they know how to do it, because they are technology providers for the whole country. When they say a word, it matters. So they took it and they immediately launched it in Punjab in a larger scale. Government had to listen because IIT is a premier institute.
Yeah.
Let us not demean them. So you go and collaborate with the right people. Your thing will be go on larger scale. And I am profit making, bootstrap, not even taken a single penny from any VCs or bank or loan, anything like that. And I'm a happy going waterman. Thank you.
Yes, sir. Wonderful. You should target not 4 lakhs, sir, 40 lakh people in 3 months. That is where you should spend more on marketing.
Because the marketing skill I learned from you. I'll collaborate with you. You take it to the market. I will make the, see, the cook doesn't get the tips, right? Quick sweats a lot in hot oven. The server who gives it will get the tips. You happily take the tips. I'm ready to cook. Thank you.
Wow.
Yeah.
Wow. That's why they call this wow, right? Yeah, Dr. Hari, I wanted to check 2 things. If people could open up their screens so we could get a picture of this very animated and committed group. Absolutely. And share it so that it seems like we're starting a movement and you're all part of it. And I also want to acknowledge there's another woman here on the screen, Mamta, who has agreed she wants to go out into the rural villages to talk with the women. She's a woman who's part of the WOW initiative, very energetic and very committed. And I saw some people come through in the chat who want to be sure they're part of this movement. So in 2 weeks, we will have a similar rural village focus with this filtration. So combining that technology with Rick's technology and Vikas's technology and Watson's knowledge, it seems like we have solutions that can address this. So everybody smile here and look at the camera if you could.
Tejashree and Larry and all that, please.
Oh, good. Yes.
Please. Larry, Tejashree.
Okay.
Who else?
Yes.
Aparna?
Yeah. Okay. Beautiful.
Okay. That's it.
Okay.
There are two others
Ready
there.
to go?
Gaurapan, Gaurapan Kupusamy. Maybe you should turn it on. And
Turn it on.
Aparna.
Okay, Dr.
Okay.
Tata, look my way.
Yeah.
Okay, great.
yeah.
Okay.
There
I
you
think
are.
you got it.
Okay.
Yeah, and I'll
Okay.
do one more. Okay,
yeah.
great. Thanks,
Yeah.
guys.
Sureshji, Mr. Suresh, you are listening to these people, the pain, the anguish of a Chandra, the indignation of, how governments are opaque, bureaucrats only look for their paychecks and their retirement pensions. What do you think you should do, or I should do, or all of us be doing to get governments to respond with some sensible frameworks? I ask you advisedly, because you are in places where you can make some reach, some influence and impact.
Sir, please unmute yourself.
You have to unmute.
Volume.
Sureshji, you have to unmute. Yeah.
And is it?
Yeah.
It's such a pleasure to participate, even a little late because I was coming from another Pune program. But then I think for the last 45 minutes was then interesting to hear all the wonderful point. At least Mary speaking was well heard. Chandra, as well as Watson Chandrasekhar and others. I could get a feel of what the issues were around, even though I missed Mason's presentation on that. I was eagerly looking for it. I'm sure I'll catch it up. But I think the larger issue that I'm able to see is that, right or wrong, the water supply schemes in all cities, including wastewater treatment, are predominantly in the hands of either government public health engineering department or a water supply and sewerage board or a water authority or a Jal Nigam. These are all parastatal organizations of the government, leaving out the PHED, pure government department. What is required is the seriousness of the whole problem has not really dawned on them still with the magnitude and scale at which they would have been okay for the 50s, 60s, and 70s, or even 80s. But 90s, 2000, and another 2 decades more in the new millennium, they are pretty bad. Last 30 years, they have never been able to catch up with the rapid urbanization and the type of problem required for water supply and the type of issues on water-related issues. They have not been able to at all deal with that. And of course, so much amount of talk on wastewater recycling has been there. Not a single city of India has done like Singapore or Israel or whatever to do all that. But that's a different history. But I think the larger issue that you're talking is not, it is not technology alone that matters, but technology did matter in the context of RO not to be done, which is a good message. I could get that. But how to get people involved in a large way? And I think some of the best example I can always see is the women-oriented groups coming, like Madam doing in Sirithulli in Coimbatore, arousing the whole citizen. Is again a wonderful lady in Coimbatore who have done the great. That means small drops. Sirithulli means small drops. What a wonderful initiative she could do. So like that, we require a lot of awareness creating group, not just department doing the work alone, but also what communities can do in this particular area. Exnora did a reasonably good job in Chennai. Some amount of arousal among them to understand the quality of water being given. Is it good or bad? What is the type of problems?
Sureshji, 2 points from you I want, or 3 points probably.
Yeah.
How do you go out, because I know you carry a certain influence in the government, to make them, sort of get to responding in far better ways than they have so far in the last 4 decades?
Yeah. I think you have a great opportunity coming on the Amrut 2.0 vision, which has just been launched.
No, Amrut has been a disaster in many ways. I'm hearing already some bad news on certain fronts. No, I'm saying, like Rick said, and many of the others have said, it's about smaller solutions. It's about taking things away from the government.
I know, that's what I'm trying to. It gives, when you get a substantial amount of funding coming on that, partnership has got to come in a very large way. At the community level, we've got to bring it into a very, instead of the top down, you've got a lot of bottom-up approach coming on that, and the communities activating in that, whether it is resident welfare associations to do in apartments and flats and other related one, or you talk of neighborhood coming, the groups that can work in that, especially to be very vigilant group over there in respect of the quality of water that is being given. How do you ensure those particular, and not just leaving some water laboratory tests being done by a department or authority where we are not sure. Nobody is able to take in India from tap water and drink that. Now that's a big, very powerful message to get across. Where you could do in all the cities of US, go to any tap and you use that for drinking. They don't have separate treatment on that. So how do we get to that particular level? It can only, that's a big message that can go across when feedback can come from the citizens in a large way about the quality of water from various parameters, the drinkable, potable quality of water that you require, what all things are required. You require a larger amount of understanding. And here again, the laboratories, others should also work together in this particular thing. Maybe the municipal corporation, ward-wise, if they are able to do something on that. Now, many big cities are large wards there. What's a smaller level of concentration area? And if we are able to get those ward representatives to get involved in that, or the RWS to get involved in that, women group to get involved in a larger way, I'm sure that will be a good way forward. Or if in short, don't put it entirely in a public sector or a government sector job or a private sector, water companies do the job, but people have to come in over there. I always say, instead of the PPP, a public-private partnership, I want public-private people's partnership. I add the fourth P coming on that. So PPP is the right answer to get answer on awareness, appreciation and application for you to understand on what are the lifeline, and that affects them morning till evening every day, 365 days. It affects them, that water, and therefore how do you get them involved is important. You got some good example told just now on that, and Tata gave us one or two good examples over there, but that should not be tokenism project. He said rightly, but tokenism has got to slowly shift towards total coverage. How do you, for a country of subcontinental proportions with about 10,000 cities and towns and about 650,000 villages. How do you do that? At least take those 10,000 odd towns in a big way. Villages will see a separate, the issues are different there. But if you're able to concentrate in that, at least 10% of those particular towns, that is the first 1,000 cities and towns we are able to concentrate with 100,000 plus population coming, I'm sure that will be a very big forward. Take a few pilot cities. I would suggest that every state, at least 2 to 3 important, one big city and one medium-sized city. And you rightly said, I want to get into medium-sized, around 50,000 to 100,000 population cities where you can make impacts easily. The scale is also easier to work on. If you're able to do 2 like that, and maybe around 30, 100 cities like that for the whole country as pilots, that'll be a good way point. And some of those good examples where women oriented. I'm very happy to hear the WOW initiative that's come over there. And these are all very interesting one. So nice to hear, Mary. And we can easily do that. It's not difficult. All I said about the Amrut cities, because they're all cities over 100,000 population. All of them are. So it's not too big. So don't get into the 1 million, 2 million, 3. Don't waste your time on that. Only the 100,000 to a million population over there. Take those particular cities over there. Since money is coming, roughly around $55 billion of funding is coming for only the water and sanitation segment. Something we can work on it. And tell this, let us put this across to the Prime Minister, the Niti Aayog, and there was a good point on capacities and ability for engineering team. The Niti Aayog's latest document brought out last month, I'm sure you must have seen. That's primarily in terms of the capacity of not only the technical engineering people, others to deal with all the city urban services. They also know
that. Surajji, you know, I mean, all the right things are always said in these official documents, you know, but you know the hard reality. Yes. I think we'll leave it there. Mary, to you and to Rick Baker, back to you.
Yes, I just want to invite everyone to join us again in 2 weeks. Make sure same time, because we'll discuss the other approach to villages. We agree we need to tackle the issue of clean water for all. And it's a combination of all these technologies. And
you know,
time to do
Surajji, we have 2 Fridays from now, we have a fantastic guy who has visited India some 27 times. John, his name is John DeYoung.
And
29th, absolutely. And I will remind you also, I'll remind everybody. He's very young and extremely inspiring. He loves India to bits. Back to you, Mary.
Yes.
I'll definitely hear. I'll also see presence Mason's presentation later after the event is over.
That's right.
It was all recorded. I missed that.
I'll send you the
Yes,
edited version.
I'll see tonight. Sir.
Sure.
Wonderful.
And we have a model with Global Waterworks that I'm going to work with Usha and Dr. Hari hopefully to implement, where we have like maybe an hour discussion, but then we have a half-hour breakout or 45-minute breakout where we can have people who are focused on the arsenic go into discussion, people who are focused on the filtration, people who are focused on the treatment go into discussion, and then we can actually have everyone have a voice, because I know we have lots of experts here who did not have the chance to communicate. And I know ICCW also has a challenge to bring energy treatment lower, and Nanda Kumar and I are going to do a follow-up on atmospheric water solutions that can become efficient, because if we can grab the water from the air, we get rid of a lot of these chemical and metallurgical problems. And so that is very exciting. And thank you, Nanda Kumar, for stepping forward on that program. You don't get out of these programs, you guys, without another assignment. So the assignment is 2 weeks. We'll see you here. We'll be able to break out, who's ever able to join, and start to structure these knowledge points for action and the pilots that Suresh just kindly acknowledged with the technologies like Vikas and Rick have brought. And Rick, Earful, what do you think? What's the next step? How do we solve this global water challenge in this generation?
Well, I feel I'm a million miles away from you, sort of geographically, but not philosophically. I feel I'm very close philosophically, but a million miles geographically. And what I would like to do is get much closer. I think that we have a very exciting technology. I'm not pushing at you, but I think that the way that in this industry technology gets adopted is by demonstration. People see it, they can kick it, they can work with it, they can see its pluses and minuses. And I very much would like to be able to establish a serious demonstration pilot of the capacity of our technology, properly documented by scientists, so that we're not selling vapor, somewhere in India, where we can really show how this technology does do what I claimed earlier on. So that's my challenge to you. We will certainly step up if you can create the opportunity for us.
Would that be urban, or would you want to look at a countryside sort of situation?
I think probably it could be either. I think the important thing is it's sort of in a controlled situation, so that we know, that we've got reliable data and controlled conditions. But it could be either. The important thing is that the data that comes out, you'll hear me say data 100 times, is reliable, trustworthy, and people can extrapolate from that data to their local situation, whether it's big or small. Our demonstration units, by the way, you saw it in that photograph, is about 10 gallons a minute, 0.7 liters a second. So which is actually, we use that to sell to the smaller community, but it also demonstrates for the bigger community. So it keeps the costs of piloting down. It's manageable, transportable, very quickly to deploy. So, we can talk about the cost.
Great. Mary, he's given us a problem statement. He's saying 3,000 liters per hour. I'm converting to liters because, Indians look at liters. And, that's 36,000 liters, let's say 40,000 liters a day. And how do I look at a solution for how do I get data of a certain guy? I think guys like Vikas, I would think Chandra too, for some of the larger community-based treatment systems that he's got, and he sells them at what? 35,000 is how much? $500. He gives you a system at 35 KLD, Rick. See, this is disruption of cost of a magnificent kind. This is what he does. Mary knows I have shared some things with her in the last few weeks. So I'm saying that with such disruption of cost and with the sort of technology that you are bringing in, maybe there is, if you work with Vikas, what he said about working where the money lies could also happen perhaps. Vikas is urban, Chandra is the countryside. I mean, to put it in a certain way. Mary, back to you.
I have very good customer base in Bangalore, sir.
Oh, wonderful. Sorry. I'm sorry.
Even company CEOs.
Okay, Rick, did you have one last response to Dr. Hari?
I would just say thank you all for bearing with my English at this time of the evening. It's been a real pleasure meeting with you all and a chance to share a passion understand better a place I don't know. I've never had the chance to visit, and I can, hope you'll give me an excuse. But thank you all very much.
Rick Bacon, what stays in my mind is that as a child, you grew up in a place which was a poor community and which had the same challenges of water that we have in our villages. And that has sort of ennobled and brought into you a certain spirit and of determination that I think speaks in everything that you say and every think that you bring to the table. What is important is, as Mary has been saying again and again and again, this is not a webinar. This is not even just a discussion. If after a morning like this for you all and an evening of this kind for us, if we don't take some very specific steps to create what Mary called roundtables and such, to bring action, I think we will go nowhere. People like Dr. Tata tell me over 1 hour of a conversation, it was more a monologue. He was talking and I was listening. And, he says, look, I can't do any more. I'm willing to help you all do whatever you can. But you guys are sitting there and you know what it means to be in the trenches. Go ahead and do it, he says, So it's nice to have people like Dr. Tata also with us, but we need people who will go and do it. And here, I'm so happy that I brought Chandra along today, Mary. What passion there. It's completely dedicated. Otherwise, you can't speak like that if you have not in the trenches, right? Anyway, I'll stop there,
Yes, agreed. And I think also we heard passion throughout this call. Amazing, because you guys are all supposed to be on holiday, aren't you? And that's what's so surprising, that you choose to do this on your holiday, which says to me, you've made work fun. This is your mission. And what I'm going to do is just put in the chat a group that Rick actually helped us start here in the community of the Global Waterworks that is focused on water quality, so that between the WOW meetings, we have a place to, what I'll do is I will put an update of this call with all of your contact information, so you can continue to chat and share ideas, share examples in that community of what works. It's all about addressing water quality. We have the lead water quality guy who works with industrial stuff in our community. We invite you all. Global Waterworks only works because of a World of Water Action Forum, people actually making things happen. So you are a means for us to hopefully stay connected, connect the world on their water solutions. And we could chat forever, but I think you need to have a little holiday. So,
I must tell you all who are not Indians here that today is the 10th day of what we call Dussehra, and it's a festival of 10 days here. And there is, across the country, I can tell you, Mr. Suresh said subcontinental. You have to ride across this country some 2,000 miles, let us say, south to north, and you'll see how amazing this festival is. It's a festival of triumphing, of good triumphing over evil. But thank you, Mary, for mentioning that. Yes, these are all guys who have no holidays. Everyone enjoys doing what he does, and therefore every day is a holiday. It is
Vijayadashmi, which means victory over evil, and that is done by goddess Durga, who is the emancipation of Shakti, power. So the woman there is killing all the evils across and bringing out the joy and happiness and the power of living peacefully in this day. All these 9 days have been worshipped on that. So killing all the evils in water and bringing out the woman power to solve the water problem would be the right call. And I am happy that it happened on a Vijayadashmi day. Thank you.
Usha Giri. You always have something very sensible to say at the end of a conversation. Oti.
Yeah, I would like to end with the very first sentence that Mary began, because I think it is so relevant. She said the future needs to be right now. And I think this platform, the WOW Tech Talks, is so beautifully complementing the WOW Action Forum to make sure that we get there. Mary also said 10 years. Well, I think 10 years is a very, very, it would be marvelous if we can do something in 10 years and make the future, a very bright one that we all are working towards.
Vikas said it's something even more audacious. He said in 4 months, 240 million people. Give me a technology that can reach people, he says. That's audacious. And if you're not going to be audacious, we are not going to win this war. It's not going to happen. Rick Bacon, we will look up to you to see what you can do to, bring things that these champions in India can make work. And you heard Nanda Kumar, the CEO of the International Council for Clean Water. He's Chennai based, and he can come in with a few things. He's a man of very few words I've seen with him, but he has things that he can bring to the table. Chandra mentioned another person called Dr. Pradeep, and how one morning dramatically he had gone and met this man in 24 hours. He brought up, and Dr. Pradeep is somebody who Nandakumar works with nearly every day. They're colleagues, working colleagues, in the campus that they work from. Keep this in mind. We've called you today. Thank you for your time with us, and thanks to Mary that she thought of bringing Rick Bacon here. I'd like you to see how you can stretch out and talk to India and see what we can do to make these things happen together.
We will do. I make that commitment. On this call is actually my colleague Patrick Franklin on the corner there, and he is covering the region. He spent a lot of time in India. We're in conversations with Crore. So we've started to break ground, and we would very much look to go further forward with that. So I would like to engage him because he's the man on the ground when I can't be there. So thank you all very much indeed.
Lovely. I wish we had heard Patrick. If he has been to India, his insights would have been very good. But like Mary said, I mean, we can go on with these conversations forever, but we need to see how we can beat it somewhere. Yeah.
Okay. Yeah. I let you go to your holidays. Happy holidays, and take care, all of you.
Right. Thank you. Thank you so much.
Thank you everyone for being here with us.
Rick, thank you, Suresh. Thank you.
Rick, I left a note. Excuse me. Rick, I left a note for you. I would like to have your coordinates, please. Rick, if you can send it in the chat box.
Thanks.
Thank you.
Yeah, I'm sure Mary will coordinate. Dr. Tata wants Rick Bacon's yeah.
Right, I will. And if Nanda Kumar, if you could stay on for just a second.
Yeah, I'm staying on, Mary. I'm just
challenge, yeah. So thanks. If you guys want to stay on, you can, but happy holidays. If not, I just wanted to acknowledge your challenge, Nanda Kumar, and how we advance that for atmospheric water groups, because we had discussed meeting November 2nd together on that.
Right. So I have drafted a note. It's a very, very basic level of note. I just put my thoughts together. What I had in mind is that this atmospheric water capture has come from mimicking nature. So there is a cacti plant, there's a desert beetle, there are various other forms of life which are able to capture water from the atmosphere and survive in the most stringent or desert hard conditions. But so somewhere it struck me that if water is, steam is condensing or water vapor is condensing to produce water, and there's a heat of condensation that comes out, that's energy. And why are we spending more energy to remove that energy, cool the process? So I'm sure there is some way by which we can bypass that step of trying to take away energy, because I don't think the cacti plant has a compressor running or something like that, which is maybe the water produced is low. So I see a lot of potential for innovation around the fact that atmospheric water capture has been around for several decades, if not 100 years. I think 1910 or sometime.
Yeah.
To the best of my knowledge, that it was first discovered or invented, but it's never taken off. And one reason is the energy efficiency. And I'm not sure whether enough has been done to see how we could, take care of the energy. That's where I'm stuck. So I really am looking forward to writing a problem statement, because one approach has been, let's get alternative energy forms which are low cost and use them so that the cost of energy comes down. So everywhere in India, I find that there are social organizations, there are corporate CSRs, there are several government schools where they would like to provide the clean drinking water to the students or children who come. But the moment they hear about the energy cost, they are backing off. The capex is not an issue. Contrary to what some of the discussions we've had today, I find that donor organizations don't mind paying a higher capex, but nowhere are they able to support it year after year with operating costs. So to bring that down, what is it that we can do? Is there, for example, I was talking to an ocean engineering professor in IIT, and he was trying to generate hydraulic force from the ocean. I mean, energy from the tidal waves, and it's something that he's been working on. All we need is the compressor is actually, compressing the refrigerant. So instead of using electricity, can we just use hydraulic force? And is there something? This is where I am. Or there could be desiccator kind of material which could be used along with these cooling agents. So there is, I think, enough scope for innovation here. If I can get some help in drafting the problem statement or the themes, then we could send these forms to people around the world. We have an organization in IIT which can help us in processing these applications and converting the ideas from lab to market. Because the idea may be there, but to take it to market involves a journey. It involves entrepreneurial spirit. It involves many aspects of business model, which many of the scientists or people who are inventing will not know. But we have a very robust process, and we take these people, the entrepreneurs, the inventors, we have a faculty attached to them. We have a business mentor attached to them and create a team. And then we put them through very rigorous boot camps, which may be a year, during which they actually, one is to develop the product from whatever idea stage to prototype to pilot. At the same time, they visit customers, end users, and understand what is the value proposition. Is it solving a problem? Is there some other bottleneck there? So they take feedback from the field, the market, and they create a business model. The problem solution fit is the first aspect that is taken care of. And then we look at the product market fit, which means what is the revenue stream? What kind of price can be paid? What will be the channels through which the product can be sold? So it's actually getting into the next level of business modeling. So at the end of a year or so, depending on the kind of applications we got and the kind of teams that we put together and the inputs that we give them, we could have a demo, and we could at various stages we could support them. Maybe at the idea stage, we can pick the top 10, 15 ideas and give them some financial assistance for developing a prototype. If that prototype stage, they get about 3 to 6 months, and at the end of it, we could look at helping them to build a product.
Yeah, that is the second
things like that. Yeah, I'm just looking at the journey ahead and seeing this. This would require support from a large corporate or a consortium of companies which can join hands with us.
Yeah.
So this is what I had in mind.
It's beautiful. And Dr. Hari, we'll continue this offline. Nanda Kumar, I know there's a Department of Energy movement here in the US to do that renewable energy too, and I want to make sure we all benefit from what's going on.
Yeah, I think our Mr. Suresh had something to offer.
I said, can we tap Bill Gates Foundation, because on this segment, and especially women-oriented group he supports that. Yeah. I'm sure some pilot projects for a few cities. Have you ever approached?
Yeah, see, the thing is that anything as far as names go is extremely speculative. We need what Nandakumar said earlier, asked for earlier. We need a document, a statement of the problem itself, and then the constructs toward the solution. We need to work on that. Like Mary said, this is something that this smaller user group is trying to do, seriously. But since you wanted to speak, I just thought I'd hear you out on this. But we need to first make, that kind of a overview proposal, as they call it. This proposal is a terrible word. I hate it. But then, we need to, we need to work on something first and then take the next step. Suresh?
Yeah,
That's it.
sure. I mean, we'll build on, I'm sure. I already said funding opportunity, government can give, otherwise foundations have to give. We require some amount of co-funding also for action, especially at local level. At government level, government can find. But if you want action to take with the citizens level, we got to find out other resources also. All I wanted was, and if you're going to take some pilots on that and big numbers that you talked about, I only give an opportunity on, because some of the segment areas are there in their work.
Appreciate it. You're right. You're right. I appreciate that. We'll have to see how we can work on this. But lots of these names are meant, all these wonderful fellows from Narayan Murthy to somebody else. They are all there in newspapers, but none of them actually fund anything. They're all working in some very incestuous ways within their own organizational kind of frameworks, So they don't work outside of it. I mean, for instance, Mr. Nandakumar is sitting inside the IIT campus. He's not able to get any money at all over the last 3 years. He's seen that it's difficult to.
COVID had complicated my life also.
Nothing to do with COVID.
It's not easy.
Yeah. It's not COVID. I think it's just some general mindset challenges that people have. Somewhere they don't see it and they don't see it. That's it. Okay, Mary, back to you.
Good. I think just the recommendation I have to keep these discussions going, but allow everyone to have input is, if it's possible, and I could show you how we do it, to have this core meeting with the breakout discussions so we can advance these initiatives once they have a problem statement created. Would that be amenable?
You are the leader. Clearly, we will fall in line. You set the tone from now on for this. That's one of the reasons we requested you to see that you guided today. But then sometimes you have to ask me to just shut up because maybe I hold the mic for too long or whatever. You should guide this for us, Mary, and we'll go with you.
Usha, is that agreeable to you? If maybe you and I meet, or I can meet with your tech people to show how we do the separate breakout rooms?
Sure.
Yes.
Yes. Okay. And Dr. Tata's at fault for getting me into all of this. I thought you guys have actually taken over what we do on our platform. So as long as we share the platforms, and we're going to have, just so you know, and Nandakumar, if you have a youth, we are having a meeting this coming Thursday with Suresh and with the team from WOW, the youth, to understand how we set up technology to support ongoing discussions and this communication through viral and social channels to bring more involved. So I'm very, very excited about that. And I'm going to shut up now because I have that same.
Mary, are you attending the VEF Tech conference in Chicago?
Yes. Will I see you there?
I'm going to be. I'm going to be there.
Definitely. I'll be there where Mariana is honored.
Yes, same. I'm being honored too as a fellow, WEF fellow.
Wow, Dr. Tata, well deserved. When you talked about Dr. Hari, I'll just correct you on one thing. Not all men are just drinking and playing cards. I've seen Dr. Hari's illustrious resume, which includes hundreds of articles or journal contributions, plus all of this change and movement, the World of Water Action Forum, but the water and waste management movement, which I've been so thrilled to be part of. And so thank you. I will see you there next week, and then jump on with these youth on Thursday.
Both Monday and Tuesday, and with Chetan is driving me, so we share the ride. So
good.
Great.
Perfect. I'll see you there. Patrick, you haven't said anything yet. Do you want to chime in here? You're on mute.
Unmute. You have to, yeah, there you are.
Yeah, I'm here to support, and I'm, like I said, I represent AMS in Bangkok, and I work with an Indian company here in Bangkok with offices in India. So I, as Rick said, I get to India more than the casual tourist.
Right. So you are east of us. So it must be 9:30 or 10 p.m. for you now.
9:30.
Okay. All right.
Yeah. Then you'll want to join. We have another tour. World Water and Waste Management is going to be meeting in Thailand in this June. So we'll keep
June.
but, we could We could chat forever on all of this. Thank you, guys. If Usha, if you can get me the recording, I will upload it to YouTube, or when you guys have it uploaded.
Absolutely. It'll be sent to you soon enough. We will, Tejasri, you will work on that, on the recording. Talk to Chirag and see how you can send a YouTube version, please. Tejasri.
Yes, sir.
Thanks. Thank you so much.
Yeah, thank you so much for hosting. Great discussion.
Thank you.
so
Thanks
much.
all of
Thank
you.
you all.
Happy holiday. Yes.
Thank you.
Victory over
Bye.
evil. Water.
Thank you. Bye.